October 3, 2025. An object from another star brushes past Mars. The interstellar visitor 3I Atlas, just 0.2 astronomical units away. Dozens of orbiters and rovers prepare for a once-in-history moment. Yet when the encounter ends, only one faint trace surfaces. Not from an official mission, but from two independent analysts poring over Perseverance's night sky images. As hours pass and data silence deepens, NASA, ESA, China, and the UAE all hold back their promised releases. The question grows sharper. Did we truly witness the passage of an interstellar comet? Or did our closest look at one vanish into bureaucratic shadow? At roughly 29 million kilometers, 3I Atlas passed closer to Mars than any interstellar object had ever come to a planet. The alignment was unprecedented. Mars, rich with orbiters and surface rovers, offered the perfect observation platform. NASA's Mars Reconnaissance Orbiter, ESA's Mars Express, the UAE's Hope, and China's Tianwen-1 all reprogrammed for this fleeting opportunity. The target, however, was mercilessly fast, crossing Mars's sky at impossible speed, its window of observability just a handful of nights before fading into solar glare. If even one instrument caught it clearly, planetary science could learn what interstellar ice really looks like, its chemistry, structure, and the conditions of its birth light years away. The only confirmed detection came not from orbit, but from the Perseverance rover's Mastcam-Z aimed at the Martian night. Two analysts, Stefan Burns and Simon Stimson, independently downloaded the raw frames from NASA's public archive within hours of the downlink. Frame by frame, they subtracted noise, aligned the stars, and built a composite, revealing a barely visible patch of light where the comet should have been. No explosion, no grand tail, just a subtle, diffuse glow right where orbital models predicted. They shared the stacked image publicly, annotated, calibrated, and reproducible, a quiet confirmation born not from access, but persistence. It wasn't proof of alien mystery. It was proof that citizen science still works, even when official data stalls. Each Mastcam-Z exposure lasted 29 seconds, 36 frames from October 3rd, 40 more from October 4th. Burns and Stimson paired every science frame with dark calibration images to subtract electronic noise, corrected for pixel sensitivity, and registered each star to sub-pixel precision. After filtering cosmic ray hits and stacking the results, the faint smudge appeared, statistically above the noise floor, matching 3I Atlas's predicted motion. They released every calibration file, parameter, and script, open source and repeatable, the hallmark of credible discovery. Then came the noise, viral claims of bright streaks in rover frames. One, a sharp line cutting through a Perseverance navcam image, was hailed online as the interstellar object in motion. Within hours, planetary scientist Emily Lakdawala checked the data. The streak's timing, direction, and brightness matched Phobos, Mars's inner moon. Another discovery from October 2nd showed a fast streak moving 10 times too quickly to be the comet. Cross-checks showed it was a sensor artifact, or perhaps a nearby dust flash. Lesson learned. In planetary imaging, every streak must pass through ephemeris matching and velocity tests before meaning anything at all. The orbiters that waited. Above Mars, 4 spacecraft had front-row seats, each armed with unique instruments. High-rise on Mars Reconnaissance Orbiter, capable of resolving the sharpest imagery. Omega on Mars Express, designed for compositional mapping and volatile gases. Nomad and Cassius on Trace Gas Orbiter, able to sniff out rare molecules and isotopes. Hope and Tianwen-1, providing wide-angle monitoring. If successful, they could have captured the first detailed structure of an interstellar comet's coma or fragments. Yet, as of October 7th, no images, no spectra, not even thumbnails, government shutdowns, data bottlenecks, and calibration backlogs. The reasons were bureaucratic, not mysterious, but the silence felt cosmic. Object millions of kilometers away isn't easy. Every orbiter relied on constantly updated ephemerides, mathematical predictions refined by the hour. They had to point blindly without real-time feedback. Each exposure was a gamble, one miscalculation, and the comet would have drifted out of frame entirely. Even when sequences executed perfectly, data downlink priorities, navigation, telemetry, routine science pushed these frames to the back of the queue. In deep space, no one gets instant replay. By October 21st, 3I Atlas slipped behind the sun, unreachable by any telescope, Earth or Mars. The conjunction blackout wasn't secrecy, it was physics. For over a month, the comet's closest solar pass, the moment it might fragment or brighten, would unfold unseen, hidden by solar glare. At JPL and ESA, imaging teams still sift through raw data, calibrating for cosmic ray hits and misalignments. They know the stakes. Release too early, and a hot pixel could ignite a global false alarm. Wait too long, and the world suspects a cover-up. Science demands patience. The internet rarely does. Preliminary analyses describe a CO2-heavy, water-poor composition, a comet chemically unlike any known in our solar system. Hints of nickel-rich metals appear, though unconfirmed. If verified, it could mean 3I Atlas formed in a radically different stellar nursery, a world where carbon dioxide, not water, froze first. Still, these results remain provisional. Only peer-reviewed spectra or high SNR imaging can settle whether 3I Atlas is just an exotic comet or something stranger. Through late October and November, SOHO's LASCO C3 will scan the inner solar system. Only if the comet brightens dramatically will it appear in that field. ESA's JUICE spacecraft, drifting near Jupiter, might get a brief deep-field chance in early November, if geometry and timing align. By December, Earth-ES telescopes will regain sightlines, a second chance to see what emerged from the solar glare. Until then, the record stands. No official orbiter images, no confirmed spectra. Only one faint, reproducible smudge from Perseverance, and a growing silence around what could be the most important interstellar visitor since Oumuamua. The question remains, did Mars witness a comet, or something we still don't have the language to describe?